So welcome Sneha. She's our esteemed speaker today. Sneha is a staff software operations engineer at Zool Live West in Pittsburgh, USA. She started her career in the exciting field of test automation in Silicon Valley. We have someone from Silicon Valley. That's good. Where she got opportunities to learn and grow in the field of QA in different domains. Sneha would be speaking on distributed testing, infrastructure using infrastructure as code, Selenium Grid, Terraform, and AWS. So if you want to know more about Sneha, you can visit the link below. Yeah. So then I will hand over to you, Sneha. You can take over the control. You can share your screen.
Yes, I'm here. I'm just trying to get the control over.
Yeah.
Are you able to see my screen?
Yeah, perfect. Yeah.
Okay. So hello everyone, I'm Sneha and thank you so much for the introduction, and I'm very happy and honored to be here with all of you. So today my talk is on managing test infrastructure as code. And so at this point, with the DevOps culture and the continuous testing and everything, modernizing the way we release software, it's important for us to have more test coverage and to make important decisions with faster feedback and along with very high quality, right? So to design such a solution that supports that, we need a more scalable and manageable and more cost-effective infrastructure. So in this talk, we're going to discuss more on this topic on how to manage and the benefits of creating a sophisticated test infrastructure using code.
मैडम 150 ml में बनना होता है ये ज्यादा से ज्यादा 250 ml 300 ml का
It's talking.
Can somebody unmute?
Hi Sneha, I think you can continue.
Okay. So the agenda for today's talk is a little bit about me, like who am I, why am I here talking to you about Terraform and infrastructure as code. And then we're going to talk a little bit about the evolution of test infrastructure. Because we're talking about how to modernize infrastructure, let's quickly take a look at how we used to do this before. And then we'll talk about infrastructure as code, understanding what it is. And then we'll talk about Terraform, an example of how all of this works. And then we'll take a quick look at the key takeaways from this talk. So about myself, I'm Sneha. As you all know already, I'm a staff software operations engineer, and I used to work in test automation. And right now, I'm automating more of the infrastructure things to make the team more productive and for developer productivity and things like that. I'm exploring that area of the things now. And I'm also the founder of Code Her Stories. So Code Her Stories is a community for people who want to level up in their careers. And we also have a YouTube channel where I interview awesome people in testing and in tech in general on their experiences in testing so far and in technology in the technology sector so far, and some best practices from their lives, and about their work experience, what worked for them, what did not work for them, how involving in the community helped gain their perspectives and things like that. So if that is of interest to you, you can go check it out. And if you have any questions, you can always ping me on LinkedIn or Twitter, and I'm pretty responsive over there. So that is about me. So I started working with Terraform when I joined, DevOps. I saw firsthand how much more easier things began to become once you started to code the infrastructure side of things. So I was very impressed by Terraform, and I wanted to start using it in my job. And I literally use Terraform for almost every single thing that I do with respect to infrastructure. Why do it manually when you can actually code it and at the same time maintain documentation and make things happen, right? So that is why I was so impressed by Terraform, and I want to show you how awesome Terraform is and how you can also start using Terraform. So beginning our talk today with test infrastructure. So since we're going to be looking at how to manage infrastructure as code, let's quickly take a look at how we handled test infrastructure throughout the years so far. So back in the days, talking about the evolution of over the years, back in the days, anyone could spin up a Selenium server on a spare machine under their desk and call it a day. Right? So, but now times have changed, and there are so many moving parts and need for efficiency as the company grows that, all needs to be very effectively managed. So let's take a look at the test infrastructure since the introduction of UI automation using Selenium. So first we started with basic test automation. Back then, right when it was introduced, the focus was actually on automating the repeatable tasks and reducing the testing time that was taken by manually running the regression test. So we mostly automated the regression test and kept running it as and when needed. So the attention was not so much on the infrastructure at that time when someone is just starting test automation, right? So the approach was very naive, if I can say so. So we probably used to automate the tests, ran them as and when needed, and then whenever we needed to speed up the testing process. And then slowly we start to use test automation execution in the nightly scheduled builds. So if we were using something like TFS or Jenkins, you could set up a cron job to run the nightly builds, or use webhooks that comes along with the different tools if they had. And then we would run the test at certain intervals, or as and when needed, maybe at night, so that in the morning when we come back, we can see the test results and the health of the previous day's builds. And then we can trigger them on build merge requests and things like that as and when needed. So that was about scheduling the builds. And then came the need for distributed testing. As the number of tests keep increasing, and as the need increases, you have a lot of tests to execute in a limited amount of time, and then you have to test your application on different browsers and different OSs, all of it parallelly at the same time. So, and then you want to reduce the time execution so that they can be run frequently and can be triggered after merge requests and things like that. So you want, the need for efficiency comes, and then the need for distributed testing comes, and after that comes introduction of Selenium Grid to help us with all of these good things. So Selenium Grid kind of allowed the execution of WebDriver scripts on remote machines, virtual Oriole, by routing the commands sent by the client to the remote browser instances as we set them up. So it solved a subset of the common delegation and distribution problems, but it doesn't, for example, manage your infrastructure and things like that. There was still some management aspect of it while using Selenium Grid. So one has to update the browsers, drivers in the nodes, and then we had to take care of the maintenance of all of that ourselves while using Selenium Grid. So then there were more ways to do this. Many organizations would immediately start thinking about creating a lab managed on-premise or in the cloud with virtual machines. So this approach works well in many places, but for other organizations, there may have been some cons, like cost and slow to spin up, or maybe they didn't have the people to do that. Maybe it was difficult to maintain and was taking up so much more time. So then came the introduction of the SaaS solutions, which would actually do this for us, right? So at that time, the introduction of a number of SaaS solutions that kind of tackled this problem for us. So they were mostly cloud-based services, which provided environments for testing with Selenium, Appium, as well as sometimes for manual execution. If someone needed the infrastructure to do manual testing, then these SaaS solutions like Thoughts Labs or Browser Stacks, all of these companies, they provided solutions. I'm sorry if I didn't say any of the companies that you liked, but all of these companies come under the same thing of SaaS solution. So with these, you got all the combination of environments with version, browsers, and all the devices that you need. And for companies that had highly confidential data, like HIPAA constraints, like for healthcare companies and some banking sector companies, etc., they had secure connection facilities as well that made it a very viable option for them. So some of the cons with the introduction of using the SaaS solutions could have been with respect to cost, because when the number of tests keep increasing exponentially, the cost also considerably increases. So that is kind of the cons maybe with SaaS solutions. But then people started coming up with their own DIY solutions that they started making with the cloud. Then came the move to the cloud, right? So migrating to an in-house Selenium Grid to the cloud, which kind of makes automated testing of web applications independent of the physical infrastructure. So this kind of eliminates the need to purchase and maintain devices to test on. So moving Selenium in the cloud also provides high availability, which kind of reduces the risk of downtime that may happen when you have a test infrastructure on-prem. So these are all the benefits of kind of moving to the cloud that we already know about. So after all of this, or even within that, but then more popular now is the rise of DevOps culture. With that comes continuous testing, right? So with the modernization of the cloud infrastructure, all of this keeps coming. And the continuous testing would mean test often, test everything throughout the pipeline. So this means that we need a scalable test infrastructure, which is also very cost efficient and reliable. So because if this is not taken care of, the testing stage in the pipeline can really become a bottleneck, and people may lose patience waiting for the test to complete. So if the testing stage is going to slow down the process, it's going to piss off your developers, and that may not be a part of the pipeline anymore. So we as testers should make an effort to make sure that everything is rock solid and it's not really slowing down the process for the devs, because we all know the patience of devs and how easy it is to make them feel like this is an unnecessary stage when it comes to building and things like that. So for all of this to run smoothly, we really need the infrastructure to be super solid. So that was about the evolution of testing, to understand why we need a strong infrastructure in our hands to make sure that we have testing added in the pipeline for continuous testing to actually become a reality. So let's look at infrastructure as code. What is infrastructure as code, right? So infrastructure as code is kind of defined, if you go check it out, as the process of provisioning infrastructure using code without any manual intervention that can be versioned and tracked using source control. So it's basically, instead of going and clicking and building an infrastructure, you are writing it as code. So it's a one-time thing. You write it and it's version controlled, it's tracked using source control. So it's basically writing documentation at the same time reusable code, right? So some of the benefits of infrastructure as code is reproducible environment. So by using code to create infrastructure, the same environment can be created over and over again, right? You don't have to manually do the same thing again and again. You just write the code once and then keep using it over and over again. And then fresh environments can be created and destroyed very easily. And idempotence and convergence. So no matter how often you apply, only the required changes that you want to apply will be applied. So and then actions are only taken if they are needed to be taken. So if you want to write a certain architecture, so if you already have run that once and then you're making some small changes, it's not going to run everything, it's not going to delete everything and run everything all over again. It's only going to add the changes that kind of needs to be made in the infrastructure at that point. And then easy collaboration, right? So it's easy to collaborate using tools like GitHub and whatever tools you use at work, because the team kind of can get a specific version of the code and create the environment as and when needed. So people can take the code and make some changes as and needed for the environment that they want to quickly create to run their code. It's easier to collaborate. Otherwise, imagine you have to if you have to tell someone how to create this, write documentation on Confluence, and then they have to manually go and do it. So this kind of makes it easier for them to collaborate. And self-service. So devs can create the infrastructure that they need, and they don't have to rely on IT anymore. They can just do it themselves to do all of these things. And then coming to the infrastructure as tools, many cloud providers usually provide their own native infrastructure as code services. For example, if you're using AWS as your cloud provider, they have their own native solution called CloudFormation, which helps you orchestrate and write code. And then Azure has its own thing called Azure Resource Manager, and Google Cloud Platform has Deployment Manager. And even private clouds like OpenStack and all that, they have their own orchestration tools like Heat. And then when you go to hybrid cloud, you can use something like Terraform, which satisfies all of the cloud, like most of the cloud providers that's there. So when it comes to infrastructure as tool code, you have a lot of options to select from, and then you select using, you start to think what goes with your use case, and then you can select from them. So let's talk about infrastructure orchestration tools, right? So what are infrastructure orchestration tools? So these are tools that can actually provision the servers and infrastructure by themselves. For example, if you want a tool to actually provision an EC2 instance on top of which you'll be adding or deploying whatever you want to add. So provisioning the actual server. So those kind of tools which can do that are called infrastructure orchestration tools. And then comes the configuration management tool. So these are tools that are primarily designed to install and manage the software on existing servers. So you use an infrastructure orchestration tool to provision a server, and configuration management tool to actually go and deploy or install or manage software on an existing server. So with respect to, if I have to give an example with Selenium Grid, then infrastructure orchestration tool will be used to create an EC2 instance, and configuration management tool will be used to actually deploy Selenium Grid in that EC2 instance. An example of configuration management tool will be Ansible, and an example of infrastructure orchestration tool will be Terraform. So while you actually choose your infrastructure as code tool, how do we choose the right tool for our use case, right? So there are some factors that you can factor in while you're trying to decide what tool you want to use. The first thing you'll think about is the long-term vendor-specific infrastructure. For example, is your company tied to a certain cloud provider at this point? Are you going to be using only AWS for like the rest of the 3-4 years or 5 years, and you have no plans whatsoever to change? So if it's something like that, then you'll probably use CloudFormation if you're going to use AWS, right? And then is it going to be a multi-cloud or hybrid cloud-based infrastructure? So is it going to be a mix of clouds, and then need to integrate with configuration management tools? The cost is also a major factor, and customer support, like what kind of customer support do these tools provide, and how much customer support do we need for solving our problems? So these are some questions that one may ask while trying to choose what infrastructure as code tool that we want to use. So having talked about the general scenario of what is infrastructure as code tools, let's take a quick look at what is Terraform as such, right? Because so Terraform is provided to us by HashiCorp. HashiCorp is the company that builds it. So HashiCorp defines Terraform as a tool for building, changing, versioning infrastructure safely and efficiently, which is nothing but also the definition of infrastructure as code, right? So it is an IAC tool. So the good thing about Terraform is it's cloud agnostic. So it's not really tied to one cloud vendor. So if you are in a position where you're not sure what cloud you want to use, you're using AWS right now, but maybe you have some Azure interests as well. So, you're not sure on what cloud specifically you want to stick to. You can always use Terraform because it's cloud agnostic. It supports so many different providers. If you look at their website, you can see how many different providers and different tools and services also that they support. And then it's got a very simple config language. It's very easy to write declarative templates in HashiCorp configuration language. It's their own thing which they created, but it's very easy to learn, and it's extendable. It offers built-in functions and modules and providers for working with cloud and on-prem systems. And then it's agentless. It only requires self-contained Terraform binary on your system. It's super easy to download and to set it up. All you need is the Terraform binary that you download from the HashiCorp website to help set it up. So if you're interested in how to set up and download Terraform, I have a video that I just uploaded yesterday so that you can go watch it if you're interested in downloading and setting it up yourself, okay? So the next thing that we have to know when we use Terraform is the Terraform commands. So the first command I'd like to start with is the Terraform format, easiest. All it does is formats the code. So if you see over here in the left-hand side of the picture, I have a very simple code of Terraform code in which I've tried to deploy an EC2 instance, right, through Terraform in AWS. So if you can see, when I use Terraform format, it returned the example.tf script to us because it formatted that code and it kind of wrote it in a beautiful way. So it it does is it formats the code. It maintains a consistent coding structure. It doesn't modify the code one bit. It is just for the beauty. And then comes the Terraform Init. So Init basically initializes the working directory, and it runs the it kind of syncs the configuration. So when you use AWS, for example, you can go to your IAM, and then you can download your access key and your security access and the security key, and then you have to sync it in this. So you have to add it in your Terraform script. So once you sync it, when you say Terraform init, it kind of goes and establishes that connection between you and AWS, and it keeps it ready for you to start applying and planning your code. So all the init command does is it initializes the working directory and syncs the configuration. Again, it doesn't modify or delete the code. It doesn't update anything in the code. It's all it does is syncs. And then comes Terraform validate. So when you say Terraform validate, all it does is it goes and checks the code, and then it kind of validates that you don't have any syntax errors and things like that, and if it's good to go. So it just all it does is validates. Again, this does not modify the code, add anything, or it doesn't delete. Hello?
Sneha, you there? Yeah, hello.
Yeah, I just got a message that something went wrong. I don't know till where I talked.
So I think the last thing that we heard was init, I think, if I'm not wrong on that.
Init. Okay,
Yeah.
cool. I'm so sorry. I didn't even realize that I lost the connection.
Yeah, actually, you got froze and we were not able to hear anything.
Oh God. Okay, sorry about that. So let me quickly go through. So init is done, right?
Yes, I think that was pretty much done, and you just moved to the next one, I suppose.
Validate. Okay. So validate is basically it validates the configuration file. Am I sharing my screen right?
Yeah.
Okay.
Yeah.
So validate basically validates the configuration file. It doesn't modify anything. Let's go to plan. So when you say Terraform plan, you can see in this picture that, I have so in this, I'm basically again trying to just provision an EC2 instance in AWS. So when you say plan, it shows you exactly what the thing is going to do, what are the different modules it's going to be creating, and it gives me the plan for me to see what exactly it's going to be doing. And then when you say apply, again, so apply basically will deploy the execution plan, but before it deploys, it again shows me the plan. It gets my permission. It will ask me for a prompt before it deploys. Only when I say yes, it goes ahead and applies. So another command that we need to know is Terraform Destroy, which is also a very powerful command because it helps us clean up whatever we've created so far with Terraform. So the infrastructure managed will be destroyed completely. Again, it will give me a plan of exactly what it wants to destroy, and then it'll ask me for a prompt whether if I really want to destroy this, and then it destroys because that's what we want. We want to clean it up, right? So these are the powerful commands that Terraform has that, we will be using these commands to do everything that we want to do. So the workflow of this, as I said, you write the config file and then you create the execution plan, you review the plan, and then you apply the changes. So the way we can add Terraform to the pipeline also, it's very CI/CD friendly. As I said, that is what we want to do, right? With continuous testing, we want to be able to create a sophisticated infrastructure using our pipeline, because that's what we want to do. So when you use Terraform, you have different options. You can auto accept it. So if you decide to auto accept, you can automatically accept plans without any human intervention. You obviously don't want to do that in your production environment if you're not very confident. So as instead, you can opt to do manual accept, where it shows you all the generated plan and anything, but someone has to be there to accept it, to understand what it's doing, and then make a decision. And then you can also generate a plan only option, where it creates still the plan. So it's good for inspecting the plan, for reviewing pull requests and all those things. This is a great option to work with that. So now that we've seen how Terraform, the Terraform commands and how it works, and all, let's review one setup where I show you, how all of this works. So the first thing we're going to do is, a CI/CD tool will trigger the build. Then we want to create an EC2 instance, and we want to install the Selenium Grid into that EC2 instance using Docker or anything that you want to use. And then it returns the IP address to us of the Selenium Grid. And then after we run the test and everything using the IP address in the EC2 instance, then we destroy the EC2 instance created. So a simple workflow looks like this. So on the left-hand side, you have a Terraform config file, which kind of creates a new EC2 instance in AWS. And it uses Ansible over here to install and configure Selenium Grid in that instance. So once you apply it via Terraform, Terraform will interact with the backend provider. In this case, our backend provider is AWS to create a new EC2 instance that you can see. And then depending on that, the new EC2 instance will be created. And once that is created, the message is returned back to Terraform with its IP address. And then Terraform integrates well with the configuration management tools like Ansible. So Terraform will call Ansible to go ahead and install and configure the Selenium Grid on that EC2 instance. And after all of this is done, Terraform will send a message back that all the things that you defined within that, Terraform config is now completed. So this is like a basic workflow of how all of this works. But if you want a more sophisticated, cost-effective way to do this, then you can use ECS with Fargate, with auto scaling and things like that. But this is for you to understand how Terraform kind of, integrates with all of this. So I think I'm running out of time. But the conclusion is, so to make it more cost effective, as I mentioned, you can have a Terraform script to run a cheap Selenium Grid in an AWS cluster with the containers managed by using Fargate Spot instances, because Spot is even more cheaper than the regular instances. And then to put it in a simpler way, the Selenium Grid, both the hub and the nodes, will run in Docker containers, and the containers will run on an ECS cluster. Then with ECS, the containers will be managed by Fargate, which immensely kind of eases running the containers from your perspective. You don't have to specify instance details. Just tell it how much CPU and RAM you need, and the backing type will, make sure that Fargate uses Spot instances. And Spot instances are basically, unused EC2 capacity that AWS offers cheaply, with the caveat that there is a small chance when you're running your instance, it can be reclaimed within a 2-minute notice. So if that is something that is okay for you, then you can use Spot instances. Otherwise, just go with regular instances. So, so to the key takeaways I would say from this is understanding how infrastructure as code can be used in a very effective way. It's a very powerful tool in your tool set, and it can be used to make infrastructure more reliable and scalable and reusable. Developers and testers can kind of create environments as and when they need to test features in isolation. It's so much more easier to do that now. And then the code that describes the infrastructure is versioned. So if you make a mistake, you can always go back to the point when things used to work, which is kind of difficult when you do it manually. You make a mistake. But over here, you make a mistake, it is okay, because you have a backup of what used to work. So it's all versioned. And the infrastructure as code can be integrated into the CI/CD pipeline, which is also a big deal, which is the way we want to proceed towards. And then reduction in infrastructure cost, as they can be destroyed when they are not needed. They can easily be destroyed. And I think I'm completely out of time, but that was all I had. Thank you for being a great audience.
Thanks, Sneha, for a really energetic talk. We have one question, so I'll just share Slido. Just a moment.
Let me stop sharing my screen.
Can you see my screen now, Sneha?
Yes, now I can.
Can you see the question which is posted? Yeah, I can just increase. Yeah, so there is one question from Smith. which says about what are the best practices for organizing Terraform